So, hello everyone, welcome to our second video of Clojure language. And you could see last video we started learning a bit about syntaxes and functions, blah 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 blah, lots of things, parentheses, spaces, and maps and brackets for vectors and list parentheses, and the scope for saying the problem that something was not a function, it was a list, and also lots of boring things, but they're going to be useful. But the format is going to suffer a few changes because if we are always explaining things for more than half an hour, you're not going to enjoy the videos. So now we are going to look at my notes, but you can do link which is in the description below. And we have 4 different files. The first one is a few examples of the formulas we are going to learn today. The second one is the syntax notes. It can be useful if you're programming because you only have to change the values because the structure is there. And then I have prepared a problem. Now I have not prepared. Rohan has found it in the internet, in the website. We have shared with you the link, so you can look for more problems. But probably we will take during these lessons more problems from this website. So be patient because if we see what interesting, we will put it in a video, or if you see a problem that interests you, you can send me the link or the problem to my email pp@slang.com. Let's go with our functions of the day. The first one is the function let, which works like defining a variable or a parameter, but we are defining here the variable. For example, I have defined name of the variable is the name of it, and it is a string in this case. And then we are going to put the function where the variable is evaluated. Why is this function interesting? Because the variable is always being evaluated there. But if we mention the variable later outside of the function let, we can have 2 different things. The first case is that the variable does not exist out of this code or the second case is that the variable has been defined before the let function. And the let, like if Clojure forgets that you have named the variable when you close these parentheses, when it's closed, Clojure says, okay, here nothing has happened with this variable. So if you are going to see it later, okay? Then we have ink number, which is a number or a parameter but has to be numerical. It's increased by 1, so listen 1. It's very simple. The map function, which is going to be used to apply a function that we are going to mention later. The function we want to each component of a vector or a list individually. Okay, so keep this concept in your head. Then you have a string function that some strings and make something like this. And merge all the strings in only one. And the strings can be also variables if they have um, uh, you have defined the variable as a string. Later, we can also define functions. That's going to be very interesting. And we have to put the name of the function. And something that is very special in Clojure is that the function can work differently depending on the number of parameters you give. So, for example, I say the function, which is called name of the function, is going to be actions 1p when I give the function only one parameter. But if I give the function g parameters, it's going to do different things, different actions. Later, you will see how does this work. And we have also the reduce function, which is not as the map function. It also works with a vector or a list, but you put reduce and later a function. And this second function is going to be evaluated first with the two component of the list or of the vector. And when it's evaluated, the output we call output one evaluated with the third component of the list or the vector. And then we get output two, and the output two is evaluated with the fourth, and this kind of things. Continuously, the process repeats, and repeats. And when we get the final output, the reduce function stops, and this final output is the solution. And then the last thing is the anonymous functions, which are structures that start with the hashtag, no space between parentheses and this hashtag. We put some functions inside the functions we want, but we are going to use this symbol, the percentage symbol, that is going to be our parameter. So outside, we are going to put a string or a number, and that's going to, this is going to be of the parameter percentage symbol. So this structure is not something that is going to unlock you new possibilities with this language, but it's useful because in programming we have two objectives. First, if we want the program to do A, B, and C, the program has that. But secondly, we have to be very efficient. So we don't want to be writing more than we need. So Clojure has created this function that will be helpful. And for example, you don't have, if you're going to use only once a function, could be very probably will spend less time if you create an anonymous function, and because you don't have to give name, numbers of parameters, and lots of things. And this symbol is created because if you hadn't, you should use the let function, but in this case it's not needed, so perfect for us. Now we're going to look at some code, and this is the output of this code. Okay, so the first thing is that I have defined x to be a string, but later I say, okay, let x to be equal to 5, int x. So the output obviously is 6 because the program, while it's inside the let function, forgets that X was a string, and now X is 5. We have used here the map function to increase by 1 all these vector, okay? Print line string, I'm Pepe and X. So as we closed before our let function, the program now says, okay, I remember that X was string. So if I say to the program, okay, print me this string, this is the original X. As you can see. More things. I defined lots of functions in this notes file. First one, hello one, says hello. It's a simple function. It's not complex. So hello everyone. Here we have it. There we have our second function, which is prepared for one input given, one name or parameter. So in this case, okay, you're going to evaluate hello2 with everyone and Rowan. On it says hello everyone and saying hello Rohan. Here we have our third function, which is more interesting because if you look at the parameters, here you have the and symbol, and that means that the function will work with any number of variables or parameters. So that's going to be interesting. For any number of parameters, please do that. And I have used the reduce function, so it's going to take lots of names and makes it later. This packet is going to be evaluated in the string function. And our last function is going to be later. Here you have the packet, and later I have used the map function. So as you can see, it's always a list. That's something that I have map the output of map functions. It's always a list. So if the input is a list, the output is a list. But if the input is a vector, the output is also a list. Always lists. Here you have the list. And as you can see, the function hello one, it was this case, hello one has been evaluated first, the first component of the vector, then with the second component of the vector, the third, the fourth, blah, blah, blah. So we have lots of different heights. And my last function is earnings. Why is that interesting? Because the function does not have a parameter, but it has a map. So that's really say, okay, I give you this map with these two keywords. If you remember the keywords of the chapter 1, they are going to be very useful. And suppose that the values of the keywords are J and S. So you're going to do these things with J and S. And then I say to Clojure, okay, you're going to take my function with a huge map, and you have all this data, but you are to search these two things using the keywords. For example, Sarah is not a component of this map, but it's the fourth. And you're going to, okay, G is 13 and S is 14. So the result has to be 27, and it has to work perfectly, as you can see. And the last thing is this function that can be also applied to a map, and it works perfectly. So that's all the theoretical stuff for today. For next week, I suggest you to do this problem that your objective is creating a function named Clojure, which is called Clojure, and this function works the same way. You give a name to the function, the output will be one for me, no, one for name, one for me. But if no name is given, the output of the function is going to be one for you, one for me. So here is and I encourage you to do the problem. If you have any difficulty, you can send me an email. And if you have a solution that is correct, please send me that solution too, because it's in programming, there are lots of different ways to do a problem, and sometimes other points of view are also really interesting, and it's really enriching um, uh, sharing this information and different ways to do these problems. So see you next week, or see me, because unfortunately I can see you, and good luck with the problem. Bye guys.